Okay, we have 83 different elements here, which includes all of the stable ones plus bismuth, thorium, and uranium. We'll get to that eventually. You'll get to see them. So we'll start with element 1, hydrogen. It is a nonmetal. Element 2 is helium. It is a nonmetal. Element 3 is lithium. It's a metal, the lightest metal. This is 1 gram of lithium. This is like several different chunks. So beryllium is next, element number 4. It is a metal, although it looks very shiny. So this is boron. It's a metalloid. Element number 5, as you can see. Does it say that? It does not say that it's element number 5, but it is. It's the fifth element. Carbon is element number 6. It's a nonmetal. Nitrogen is element number 7. It is also a nonmetal and a gas. Oxygen is element number 8. It's a nonmetal. It's getting hot in here. I don't want to turn on the fan though. Okay. Oxygen. Okay. Fluorine is element number 9. This is a pure fluorine sample. It was $400 because they have to do some sort of process to, get it to not react with the glass. Element number 9, fluorine, nonmetal. Element number 10 is neon. It is a nonmetal. And commonly in neon lights, basically. Here we have sodium. It's a metal. Element number 11. A very soft metal, which you could probably cut with like a butter knife, I think. So, magnesium, element number 12, is a metal. I mean, you might be able to tell that by its color and its metallic surface. Aluminum is element number 13. It is a metal. Okay. We get to silicon. Silicon is a metalloid. Wow, that's pure. That's, what is that? 6 nines pure? That's only metalloids. I only see metalloids that pure. I don't know why, but that's just what I see. But yeah, silicon's a metalloid, element number 14. That's silicon. There's a shard up there, but this is specifically black phosphorus, but it's phosphorus. Element number 15. It is. This container's sticky for some reason. But yeah, it's element number 15. It's a non-metal. This is sulfur. It is a non-metal and is element number 16. Chlorine is element number 17. It is a non-metal too. And finally, for that period, we have element number 18, which is argon. It's a non-metal. Potassium is element number 19. Yeah, argon was 18. Potassium is 19. It is a metal. Also kind of like sodium, and it's like the same type of ampule and everything. It has similar reactivity or similar chemistry and all that stuff. Soft metal too. Okay, element number 20 is calcium. You might have heard of it. It is indeed a metal in its pure form. So, well, obviously all these elements are in their pure form because that's what elements are. Yeah, calcium is a metal. Next we have scandium, element number 21. It is a metal. Next we have titanium, element number 22. It is a metal, also very well known. So Vanadium, element number 23, it's a metal. Chromium, element number 24, it is a metal, obviously. Manganese, okay, this is manganese. I would show you some more manganese that I have, but I just want to show you just a sample, because it's like not too oxidized, so. That's manganese, element number 25. It is a metal. Oh, yeah. I don't think I've been saying the numbers, have I? 21 for scandium, 22 for titanium, 23 for vanadium, 24 for chromium, 25 for manganese. Element number 26 is iron, a metal. Also, it's ferromagnetic, so. Cobalt is element number 27. It is a metal. It's also ferromagnetic. Here, let me actually prove that. Let me actually prove it with a fucking magnet. Here is some magnets. I gotta be careful with the iron to not like break the ampule or something. Let's do this very carefully. As you can see from the iron, it is definitely magnetic. Okay. So with the cobalt, it's also magnetic. Okay. Element number 27 is cobalt. Element number 28, after 27, yeah, is nickel. This is a Canadian nickel in 1965. Well, in the specific years, they made them out of pure nickel. And this happens to be one of those years that they made it out of pure nickel. And it's also ferromagnetic. So if you stick it to the magnet, it sticks to it. So here, I just want to test something with gadolinium real quick. Yeah, the lanthanides usually stick to a magnet too. Just a little bit. Especially gadolinium for some reason, man. But yeah, gadolinium is supposed to be ferromagnetic below a certain temperature. Let's put those magnets back up. I just wanted to show you gadolinium so I can put the magnet back up. Okay, where was I at? Nickel. Okay, next is copper. Oh yeah, the rest of the metals should not be ferromagnetic. They are paramagnetic or diamagnetic. I think copper's diamagnetic. I don't know. I'm not sure. But this is copper, element number 29. It is a metal, just like nickel. Nickel's a metal too. Element number 30 is zinc. It is a metal. Element number 31 is gallium. It's indeed a metal. It'll also melt in your hands because its melting point is very low. Like not room temperature like mercury, but like, I don't remember. It was like 100 degrees Fahrenheit or something, but pretty low melting point. It's also pretty interesting to play with. Element number 32 is germanium. It is a metalloid. You can tell by how shiny it is. When you polish up a metalloid, they usually get really shiny, so you'll see what I'm talking about. Because every time I talk about them, and I'll show you it, it'll be really shiny. Arsenic is element number 33. That's a metalloid. Most people are afraid of arsenic because they think of it as a poison or something, but you could probably handle it in your hands and be fine. Just don't eat it. So this is selenium. It's element number 34, and it's a non-metal. This is element number 35. It is bromine. It is also a non-metal, and it's also a liquid at room temperature. Bromine, this is one of my favorites, samples of any element, actually, is bromine, because it's so interesting. There's no other red liquid element, so, I mean, there you go. We have krypton, that's element 36, it's a non-metal. Oh yeah, hopefully I said bromine was a non-metal, because it is. So is krypton. We have rubidium, It is a metal, element number 37. I just have 5 grams here. Again, soft like all the alkali metals. You could probably scrape it up with a knife or something. So next we have strontium. Element number 38, it's a metal. Yttrium is next, element number 39. It is a metal. Element number 40 is zirconium. It's a metal. Element number 41 is niobium, and it is a metal. Now, element 42 is molybdenum, and it's a metal as well. All right, so the next element is the first element that I do not have because it is very radioactive. That would be element 43. That's technetium, which I do not have. You can buy a few like micrograms of it for the low price of $6,000. So, yeah, that's why I don't have any. Next is element 44, ruthenium. We get into the precious metal territory. Ruthenium is element number 44. It's a metal. It's also a precious metal, so that's that. Okay, now we have one of the most expensive metals, rhodium, element number 45. Pretty much the only reason I redid this video is because I got this, and I used to have that 1 gram rhodium sample over there. If it'll focus, yeah, see? Now I have an actual coin. So this is a lot of money. Just like, I'm not gonna tell you how much, but it's a lot. Actually, I will tell you how much. It's in melt value about $300 to $400, just this coin. But this amount of gold would be worth $200, so it's significantly more valuable, at least at the moment. But yeah, that's element number 45. It is, not only is it a precious metal, but yeah, that indicates that it's a metal that's precious. Very rare too, like the second least abundant metal in Earth's crust, or any element in Earth's crust, I think, other than the radioactive ones. We have palladium, element number 46. It is a precious metal, so a metal. We have silver, element number 47, which comes after 46, obviously. This is a 4/9 fine silver Canadian maple leaf from 2022. So, yeah, silver's a precious metal, obviously. Probably one of the most well-known, other than gold and platinum, but, you know, there you go. Next is cadmium, element number 48. This is a metal, but not a precious metal, just a metal. Although it is pretty rare, same with indium. Not as rare as silver, but almost as rare as silver. Like, they're, cadmium and indium are, you know, somewhat rare. Actually, they're much rarer than all these other metals I've been talking about. Indium, element number 49, is a metal. Not a precious metal, but rare, you know, like cadmium was. Tin is element number 50. It is a metal. It is not nearly as abundant as all these other metals, but it's not as rare as indium or tin even, and definitely not as rare as the precious metals. So, there's tin. Antimony is a metalloid. It's element number 51. It's a metalloid, not a metal. It's a metalloid. Next we have tellurium, which is the third least abundant element. That's why I said element, because it's not a metal, it's a metalloid. But it's tellurium, element number 52. It is, I don't know the exact ranking, but it's one of the least abundant in Earth's crust of any element that's stable. So, which is strange to me, but whatever. Iodine is element number 53, and that is a non-metal. Xenon is element number 54. It's a non-metal. All right, so for all the remaining elements, they're all metals. I'll indicate when we get to precious metal territory, but from now on, they are all metals. And that is because after bismuth, I don't have polonium, acetine, radon, francium, radium, actinium, or protactinium. And specifically in between those, what was it? Astatine and radon are non-metals. So that's where the end of that period was, just right there. And you skip a bunch to get to thorium and uranium. That's why the rest are all metals. So I don't have to say that anymore, thank God. Element number 55 is cesium, clearly a metal. And that's the last time I'm going to say it for the rest of the video. So barium is element number 56. All right, we get to the lanthanides. Element number 57 is lanthanum, obviously, because that's what the lanthanides are named after. We got element number 58, cerium. Element number 59, praseodymium. Element number 60, neodymium, which is used in neodymium magnets in some percentage. Yes, that is true. Okay, we skip promethium, it's radioactive. Then we get to samarium, element number 62. Europium, element number 63. Yes, it is a metal, even though it doesn't look like it. It's just highly oxidized. Actually, I don't know how oxidized it is, but it is oxidized. Element number 64 is gadolinium. Like I said, ferromagnetic under a certain temperature. Also stable. Or not stable. Obviously, it's stable. Non-reactive with oxygen. These lanthanides, the first lanthanides, are kind of reactive with oxygen. That's why they're in ampules. But then gadolinium and after the lanthanides are not in ampules because they don't really react with oxygen for some reason. I don't know why the break is at gadolinium, but whatever. 64. Terbium is 65. And yes, the lanthanides are very hard to separate from one another because they're all chemically similar. So, dysprosium is element number 66. Holmium is element number 67. Erbium, element number 68. Pretty cool. My finger's getting itchy. Okay. Thulium, element number 69. Ytterbium is element number 70. You can see it has an interesting color to it. Now there is a chunk missing out of it there. That's just how it came. Whatever. I don't really care that much. Because most of this is, or actually 99.9% of this, at least, is ytterbium. Oh yeah, that's another thing I wanted to say. Let's see. Zirconium. I think zirconium and hafnium were hard to separate from each other because, no. Was it niobium and hafnium? No. Yeah, zirconium and hafnium. They're hard to separate because they're chemically similar. They're both in the same block. Here, look, I'll go to the... Trust me, this is relevant. So zirconium and hafnium are hard to separate because they're chemically similar, right on top of each other. Which, you know what that means if you know what the periodic table is like. So, but the reason I say that is because the only two samples I have that are below 99% pure are my beryllium, which is 98.7% pure, and I think zirconium, was 98.7% pure. I think. It definitely wasn't hafnium, because my hafnium was pretty pure, I think. But yeah, ytterbium, the next is lutetium. That is element number 71. I haven't been saying that they're metals because they're all fucking metals. The rest of them past xenon are metals. Hafnium, element number 72. That's what the 1% is in the zirconium. There's because it's hard to separate from it. You could separate it. You just have to go through several different cycles of the same thing over and over again, and that costs money. So, tantalum is element number 73. You can see it looks a little brighter, a little more reflective than some of the lanthanides were. Okay, we get to the really dense metals now. The density has increased by a lot, just from tantalum to tungsten. We have one of the densest elements is tungsten, element number 74. Then rhenium, okay, we're finally get to precious metal territory. Rhenium is element number 75. It is a precious metal. I say that based on how it's not usually always considered a precious metal. Sometimes it is. But the reason I definitely say that is because its percent abundance is very, very low. So, in the Earth's crust. So that's why I say that. Okay, we have osmium. Element number 76 is a precious metal as well. It is the densest and hardest, I guess the hardest. But yeah, it's definitely the densest metal and element, I think. So this is 10 grams of osmium. It doesn't look very big because it's very dense, but it's definitely weighs 10 grams. That's osmium, precious metal. Oh, 76, element number 76. Element number 77 is iridium, the second densest and least abundant metal in Earth's, and most expensive metal on the market, and least abundant in Earth's crust, and the second densest element. So I guess iridium wins overall in terms of being interesting. Maybe osmium is cool too, but iridium. There's iridium. Element number 77. Platinum. You've heard of it. Element number 78. Yep. It's a metal, obviously. I don't need to say that. Gold is element number 79, and this is beautiful, obviously. Very pure gold here. Okay, then we have mercury. That is element number 80, right after gold, which most people don't know. So it's also not as dense as like tungsten, rhenium, osmium, iridium, platinum, gold. They're all very, very dense. But then once you get to fucking mercury, it just suddenly stops becoming dense. It's still pretty dense, compared to water. And, lead's right over there. Lead's kind of dense. So, but yeah, there's mercury. Element number 80. Thallium. Here's the thallium. Element number 81. This is very poisonous, very deadly. If you were to touch this, you might die of thallium poisoning. So, depends how long you touched it for, but I think you would still get sick. Lead, element number 82, does not have a good reputation, but that's only because people didn't understand the true implications of what lead does to you. So, it's not really that dangerous, unless it's in like a compound formed or something. But even just touching lead metal is kind of dangerous. It could absorb through your skin and harm you. So that's why it's in resin right here, and I'm not touching it. Next, we have element number 83, bismuth. Obviously a metal. The next element after that is radioactive. It's polonium, which is a metal. Then acetine. So polonium's 84. Here, let me just go to my periodic table. Polonium. So there's bismuth. So we got mercury, gold, mercury, thallium, lead, bismuth. Then polonium, 84, metal. Not everybody agrees on that, but we're pretty sure it's a metal. Acetine's a non-metal. It's 85. Obviously, everything past bismuth is radioactive. Bismuth is very, 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 very weakly radioactive, but basically non-existent. You would not be able to tell. Radon is a non-metal and a noble gas, technically, but radioactive. Element number 86. Francium's a metal. Element number 87. Radium's a metal. Element number 88. Actinium's a metal. Element number 89. See, it's not even worth me saying that it's a metal, because if you were to isolate these, I think the half-life is pretty low. So even if you did see it as a metal, it wouldn't be that impressive. Well, actually, it would be very impressive, but what I'm saying is I'm not sure you'd be able to see that for very long. Really depends on the isotope. Okay, thorium I do have, element number 90. I do not have element number 91, which is protactinium. These are all metals, by the way, except for, actually, all the way down it's metals. Metal, all the way down, until tennessine and oganesson, which should be not metals. We don't know what tennessine is. It could be a metalloid or a non-metal, but it's definitely not a metal. Neither is oganesson. Livermorium's probably a metal. But yeah, there's thorium. I have that. I don't have protactinium, and I do have uranium, which you're about to see. Okay. So we skipped all the way from 83 to 90. As you can see, I showed you on the periodic table. That is thorium. Very oxidized thorium, but still thorium. Thorium metal. Although the thorium oxide on the surface is not metal, but whatever. So mostly what you're seeing, I don't know what percentage of what you're seeing is metal, but probably some percent. And then we skip one. We skip protactinium, which is 91. If we go from 90 to 92, this is the last element that I have. It is actually very dense. Pretty comparable density to gold. Like 19 point something grams per cubic centimeter. But yeah, this is in an ampule, so this, what you're looking at here, is actual uranium metal. Element uranium-238, the more common isotope, is what this is. Not the kind that you make bombs out of. This is just the non-fissile one. So, yep, that is everything. The whole stack of elements. Thanks for watching.